Okay, everyone. In this video, we will show the tutorial 4. Here we have the axisymmetric problem here. So this is a pressure vessel. We have the if we rotate this view by 360 degrees, we will have a three-dimensional pressure vessel. So this is, we have the z-axis shown here. That's the axis of symmetry. So we rotate it. So we should be able to use axisymmetric elements to solve this problem. So here we open the Abaqus and we change the work directory to tutorial 4. So select tutorial 4 here. So now we create a geometry. Please keep in mind that we can either create the geometry by sketches, or we can just create the part directly. So this time I'm going to show you how to create the part directly other than import a sketch. And we create a part. So it's modeling space, it's axisymmetric, deformable. We will deal with the shield, as we have the edges there, and we have the thickness of the over there. We go so the axis the size doesn't matter here. We have over here when you have the axisymmetric, we have the axis shown as the green, and please keep in mind that this is the z-axis of our model of our pressure vessel. So that means when we create a model, it's better to rotate this by 90 degrees. So we create the bottom edge and the quarter circle here, because this is a axisymmetric as well as symmetrical about the r-axis. So a quarter model would be adequate in this case. So we create the model. So we have firstly we create an inner face, and we can have the rectangle plus a circle. The rectangle is 0.5 and 0.5, and the circle is 0.52. I'm going to show you here. Start from 0. Doesn't matter. To 0.5. So this direction is 0.5. And this direction is 0.52. We have 0.5 and the 0.5. And then we draw a circle. The circle. The arc. We have the center here. One here. The other one goes to on top over here. So this is the circle, and then we press the cancel to escape there. And then we need to delete the unnecessary ones. Can trim this one, this one, this one. This is the inner surface. As long as we have the inner surface, we can offset that by 0.5 meters. 5 meters. We go offset. We'll offset this one. Okay, 0.5 meters. And the right side, we go to the outer side. 0.5 is the inner radius. That's correct. So that's it. the surface. So then we collect the open edges there. OK to cancel. OK, cancel. Okay, so we have the geometry correct. Click down. So that's the geometry. Remember to save the model. And the model is the model. So we have the work directory. Yeah, so this is the model now. So next step, we define the property. We have the material property, 200 gigapascal per 3. Mechanical, so 200 megapascal. The 0.3. That's the material. We define the material with section. Axisymmetric. We just do the solid material and assign everything here. So we have the solid homogeneous material attached to there. So we are done with the property. Next, assembly. It's using dependent. Pretty straightforward. Nothing changes here. And then go to the step. Create a static step. We go to the load. So now we apply the load. Please keep in mind this is the Axisymmetric here. So basically, the software should deal with this as the Axisymmetric. So everything is Axisymmetric here. So the only thing we need to do is to constrain the bottom so that we have the symmetric one axis. Define the symmetry here. So it's y axis symmetry. There will be no movement in the right direction. That's defined. It's defined. How about that? Let's check what we have here. So we have the boundary condition. Left edge. We wanted to have the left edge axis symmetry too. Okay, constraint here too. So that's the axis symmetry. We want to fix that into of the emission. That's it. So then we can apply the pressure. The pressure is how many pascal is 100 megapascal. So we wanted to use megapascal here. We have the pressure. Select this line, and we press Shift to select both of them. Uniform. That's 100 megapascal. Please keep in mind we use meters and newtons here. That is a megapascal. Click OK. So we have the pressure applied here. So everything is ready with the geometry and the load. Next step, we do the mesh. Go to the mesh modular, and let's say what size we use. We will use the mesh. So we will use the. So firstly, we would like to use the. We would like to separate the side wall from the end cap. And then we'll use 0.02 sizes here. And the software can know the type of problem. That's one of the partition over here. So there is a partition. We can partition face. Then we partition over here. Click the partition over here. And create my. Then click cancel. Right down we have the partition. So we would like to have the mesh into a separated partitioned regions. So we use the size, wall size by 0.02, and we would like to have structured quad side type. So select the edges. Like to have the size 0.02, and we control the shapes, the quad only structured. And then we select the type. We'll use the 8-node quad system there. Axisymmetric stress, we'll use quad, so 8 node. So that's a quadratic formulation. And then we do the mesh. So yeah, we have very good structural mesh. Everything is all the meshing shapes close to a square one. Click OK, and then we can analyze it. Create a job. Do we need to do any the default one? And so we will not have any different oops. Create a job and click OK. Click submit. The work submitted. Then we can come back. Okay. Say what type of results we will show. We will show the deformed shape and undeformed shape. We show the vertices, stresses here. Yeah, and we can also show we can also show some from the stresses at the different locations here. You can see. So we are done. We go to the results. So yeah, we have the job over here. And the other ones on the from tutorial 3, you can close it. Just focus on this one. Show the stress. So this is the when we say stress, we can also show the shape, the stresses on deformed and undeformed shape. The vertices, the maximum vertices is given. That's in Pascal. Pascal, the largest is about 1.9 gigapascal. We can compare the results. It's shown here. And this is the average. You can show the average on average. So this is the vertices, stresses. You can also show the stresses along some lines here. And so there is a tool. It shows query the plum values. Can show select some results from anywhere. Show the results for elements unknowns. The values, for example, if you would like to know the value here, and the results can be shown by these values. That's how we can show the results here. But I'm going to leave the interpretation of the results to you. So I will assign several problems for you to better understand the results here. For example, results. So what would be the results for the R? The sigma R, sigma R, that's the S1 one. There will be the sigma R and sigma Z. Sigma Z, that's S22, 2, and then sigma R tau, sigma Z, all the process. We can also show some force, and that's the sigma theta, that's the perpendicular to the grid. There are also stresses there based on the formulation of the axisymmetric information. So I will leave the practice to you. I think that's all for this tutorial. Thank you.